One thing you need to understand before we start talking about the formulas of ionic compounds is that even though ionic compounds are made up of charged ions, they are going to be neutral overall. If I were to take this ionic compound right here and separate the ions, I would end up having 12 cations that each contribute a charge of +1 and 12 anions each contributing a charge of -1. So overall, the total charge from all the cations would end up canceling out the overall charge from all the anions as well. So even though it's made up of ions, the total charge from all the cations is going to cancel out the total charge from the negatively charged anions. So what we're going to look at are formulas and names of ionic compounds. The first thing you need to understand is, what is a chemical formula? A chemical formula is going to show you both the types and numbers of atoms in the smallest representative unit of a substance. So what you're looking at right now is the formula of an ionic compound of beryllium nitride. What you need to understand is what those little numbers are called. They're called subscripts. So moving forward, when we're talking about a chemical formula, those little numbers, we're going to use the word subscripts. The formula of an ionic compound is referred to as a formula unit. What that formula unit is going to show you is the simplest ratio of cation and anion needed in that ionic compound to make it neutral overall. I need this many cation for this many anion in this compound in order for that overall charge to be 0. So here's the formula unit for sodium chloride, NaCl. What that formula unit is telling me is that for every one sodium ion that has a charge of +1, I need one chloride ion in order to make that compound neutral overall. Let's look at another example. So we have the formula unit for magnesium chloride is MgCl2. What that formula unit is showing me is that for every one magnesium ion that has a charge of +2, I need 2 chlorides each with a charge of -1 in order to cancel out the total positive charge. So the formula of an ionic compound is a formula unit, and it's showing you the ratio of cation to anion needed in that lattice structure to make the compound neutral overall. The method that we're going to use in order to figure out the formula of an ionic compound is called the crisscross method. So let's go through a couple examples and I'll show you how to use the crisscross method in order to figure out the correct formula. My example asks to write the formula of the ionic compound that forms between lithium and oxygen. My first step is always to write the cation on the left and the anion on the right-hand side. Lithium is a metal. Metals lose electrons to form cations, so lithium is going to be my cation. Lithium forms an ion with a charge of +1. So I write lithium symbol and a +1. Oxygen is a nonmetal. Nonmetals gain electrons to form anions. Oxygen will always gain 2 electrons to take on a charge of -2, so I write that anion like that. Now what I'm going to do is I'm going to figure out what the subscripts are in the formula unit by using the crisscross method. The first thing that I'm going to do is figure out what subscript lithium needs. So in order to do that, I look at the opposite ion's charge in order to figure out what the subscript should be. Oxide has a charge of -2. What that tells me is that lithium needs a subscript of 2 in the formula unit. Now I can figure out oxygen's subscript. Lithium has a charge of +1. That tells me that oxygen in that formula unit needs to have a subscript of 1. If the subscript is a 1, you don't write the 1 down by leaving it blank. It's implied that it's a 1. Based off of that formula unit, I can tell that the ratio is going to be for every 2 lithium ions with a charge of +1, I need 1 oxide with a charge of -2. My next example is write the formula of the ionic compound that forms between calcium and sulfur. Once again, I'm writing the cation on the left, the anion on the right, and I use that crisscrossing method to figure out the subscripts. So I can figure out that calcium needs to have a 2 next to it as its subscript, and then I could figure out that sulfur needs to have a 2 next to it as well in that formula unit. The one thing you need to be careful of is always check the subscripts. If you can reduce them down, you need to reduce them. So we have Ca2S2. Both of those subscripts can be divided by 2, and we still get a whole number. So I'm going to reduce them down, and I'm going to get CaS as the correct formula. What that formula unit is telling me is that for every one calcium ion with a charge of +2, I need one sulfide that has a charge of -2 as well. So the key thing we're looking at on this slide is that when you do that crisscrossing, always check the formula. If you can reduce the subscripts down, you reduce them down so that you have the lowest possible ratio. All right, so we have some practice problems, so you can pause the video and practice to see whether or not you're able to solve them. All right, so for that first one, it asks you what is the formula of an ionic compound formed between potassium and oxygen. So I write the cation and the anion out. Remember, cation on the left, anion on the right. I do the crisscrossing in order to figure out what the subscript should be next to each element in the formula unit. I figure out that the correct formula unit is going to be K2O. Based off of that formula unit, I can figure out that the ratio needs to be that for every 2 potassium ions, I need 1 oxide in order for it to be neutral overall. My next example, what is the formula for an ionic compound of magnesium and nitrogen? I set up those ions, cation on the left, anion on the right. I do the crisscrossing in order to figure out what subscript needs to be next to each element in the formula unit. I get Mg3N2. I can't reduce the subscripts down, so I stop at this point. What that formula unit is going to tell me is that for every 3 magnesium ions that have a charge of +2, I need 2 nitrides in order to make the compound neutral overall. All right, next, check for understanding. What is the ionic compound between aluminum and oxygen? The correct answer for that is going to be B, Al2O3. So I would set the problem up like this: aluminum ion on the left, oxide on the right. I crisscross to get Al2O3. The ratio that this would give me is that for every 2 aluminum ions that have a charge of +3, I need 3 oxides with a charge of -2 each in order to make it neutral overall. What is the ionic compound formed between magnesium and oxygen? The correct answer is going to be D. You need to be careful. You set up your ions like this, Mg+2, O -2. Then you crisscross and you get Mg2O2, but you need to reduce those subscripts down so that you get MgO as the correct formula. And that ratio is going to be for every 1 magnesium ion with a charge of +2, I have 1 oxide with a charge of -2. So in your classwork homework packet, you can complete numbers 25 through 28. For number 28, only do the formulas for each one. All right, so you can check your work for number 25, 26, and 27. 28 required you to use crisscrossing in order to figure out the formula for each problem. The thing with formulas is there is no gray area. You're either getting them right or wrong. So if your answers are not matching mine exactly, then they are wrong. You need to figure out what you are doing incorrectly and fix your mistake. The next thing that we need to look at is figuring out the names of ionic compounds. So a binary ionic compound is only going to contain a metal and a nonmetal. In order to name a binary ionic compound, you use the following rules. The name of the metal is going to stay the same. However, the name of the nonmetal needs to be changed. You need to change the ending to I. So for NaCl, sodium stays the same, but chlorine, the nonmetal, you need to change the ending to "ide." So the name of this compound is going to be sodium chloride. All right, so you can practice the following two problems. Number 1 is potassium iodide, and number 2 is lithium sulfide. Next one, name the following compound. So that is going to be sodium sulfide. The correct name for SRO, that is going to be strontium oxide. The correct name for Al2O3, that is aluminum oxide. As you practice more and more of these, you'll get more comfortable changing the ending of the nonmetal to "ide." So far, all of the formulas that you've completed, I gave you the name of the metal, the name of the nonmetal, and then you did the crisscrossing from that. What you need to be able to do moving forward, now that you know how to name ionic compounds, is if I give you the name, you should be able to produce the correct formula. So if you were given aluminum bromide, you should recognize that aluminum on the left is the cation and bromide on the right is going to be your anion. I'm following all of my same crisscrossing steps. I write the cation on the left, the anion on the right. I then use the crisscrossing in order to figure out the subscripts for each element in the formula unit, and I get AlBr3 as the correct formula unit. So now you're going to be given the actual name of the ionic compound, and you need to be able to produce the correct formula. All right, so in the classwork homework packet, you can go back to number 28 and now name each of the compounds. All right, so for 28A, it's lithium sulfide. B is going to be beryllium nitride. C is going to be strontium chloride. D is aluminum oxide. E is magnesium sulfide. F is sodium phosphide. G is barium nitride. And H is francium fluoride.